Welcome to MCC Tech Days 2020. I'm Brian Such, Executive Vice President of Marubeni Citizen-Cincom. And on behalf of the entire MCC team and our national distributor network, I would like to thank you for joining us today. As we changed plans after IMTS was canceled, we knew we needed to create our own alternative to IMTS. Our outcome is to offer 4 days of live demos streaming from all 4 MCC offices, demoing Cincom and Miano machines, our tooling and accessories, along with our automation department offerings, all of our MCC technology. We also always have heavy dealer support to our IMTS efforts and knew we wanted to include our dealers in these tech days. Please enjoy this next demo. We invite you to ask questions live as needed. Our team is happy to answer any questions you may have. After each session, we will share some videos from our distributor team and also update all with our promotional efforts along with financing options. Thank you again for joining us in MCC Tech Days.
Hi, and welcome to MCC New England. Thank you for joining us today for our MCC Tech Days. We're here, I'm Mark Carlson. I'm a regional manager for MCC here, one of the 4. And this is our showroom. MCC New England consists of 3 facilities. The showroom here, which consists of sales and applications. Then we have our tooling, accessories, and engineering, along with, high pressure coolant pumps. And we also have a manufacturing facility. So again, thank you for joining us. I'm going to introduce you to Les Royce and Zach Hughes, who will take you through the Miano. Thank you very much.
Zach Hughes. I've been with the company for 23 years, started out in engineering and been in sales for the last 9. And Zach is one of our Miano applications engineers. So we'll be presenting Citizen Machinery's Miano B&E 51 MSY. So again, we want to thank you for taking the time to watch this presentation, and hopefully at the end you'll have a few questions. A little bit about how this is going to go, this presentation is going to go is I'm going to start out going over some design and construction and some of the specifications of the machine, and then I'm going to hand it over to Zach. He's going to get into a little bit more detail on capability and a few control features that we think sets us apart from others. So, and then after that, we'll actually show Zach's part running. It's actually going to be a narrated video, so we can actually hear him talk without hearing a machine cutting behind you, and then he'll narrate that as we go, and some other little narrated videos. So I'd like to start out with just saying that Miano has done a really good job of actually coming up with some unique designs, and many of those are around what we call superimposition. So in this particular machine, it's a double turret machine, but it actually approaches the capability of a triple turret machine. And that's due to the superimposition capability and some unique tool holders. John, I don't know if you can zoom in on this or not, but you'll see a double turning holder in this case. And I can actually have 2 operations happening simultaneously with this particular tool holder in this turret. So I can program this side to do its own turn, this side to do its own turn, but this side here will actually follow, the subspindle cutting will actually follow the movement of what's happening with the turret on the main side. So that's superimposition is a big buzzword for us. It's in a ton of our machines. It kind of started out on the Citizen-Cincom side of things, and it just morphed into the Miano product line. And these are other demonstrations that we'll have later in the week. And pretty much all of them have that superimposition capability. So for instance, I've got a single turret machine here, and with the superimposition, it actually gives us almost the capability of a twin turret machine. So that's just a little bit on, a little bit of the history of Miano and where I think we've kind of fit. We're in that little niche market between a double and a triple turret machine. The Miano, the B&E is actually a highly accurate, very rigid, complex, and both turrets are capable of, they both have 12 stations on each turret. I can put live tools on any one of these positions. Little bit about the the mindset behind the construction of this machine and design of this machine. It was really designed to be really a great bar machine. When I look at, they looked at this having, 2-inch max capacity for bar stock, but that bar stock could be 12 feet long. So they build the machine around being able to handle that for years. And it's been proven to be a great design forever for being a bar machine. So part of that is it kind of starts out with the casting and the design of the casting, and then it moves up to essentially all hand scraped ways. Most of them are boxed ways, except the X3 axis is a dovetail way, but essentially they're all boxed ways. And they've also built the spindles around, being able to be durable enough to handle that load of a 2-inch bar, 12 feet long. So we've got 3 sets of double row bearings in both spindles, and it's kind of an assortment of cylindrical bearings and also angular contact bearings. So a little bit of my history I have to throw in there with Miano dates back to the early 80s. I worked for a large aerospace company, and that's all we had for bar machines as far as lathes were concerned. And to this day, 30-something, 40, almost 40 years later, those machines are still running in that factory. When Miano became part of the Citizen Machinery family, and we went out and visited customers that had Miano machines, they've had them for years. So it's kind of a testament to the product line and the longevity of the product line. And you ask customers, and a lot of the buzzwords are that these things just last forever, been holding tight tolerance for decades. And for those users out there that have Mianos, I'm sure that you can attest to that. So a little bit about the machine itself. So it is a compact machine for a 2-inch machine. It's basically weighs in at just under 18,000 pounds. And again, all the slides are all hand scraped ways. The turrets themselves are all tang drive. So I've actually got essentially tang drive, meaning that if I turn on one tool, that's the only tool that rotates. It's not the whole turret. And I've got on the turrets themselves, as far as talking about live tools, I've got 6,000 RPM on the live tools standard, and we can add to that as well, and with speeders and NSKs and that sort of thing. So there's many types of different tooling configurations on that. So digging a little bit more into the turret themselves, or the machine design itself, I've actually got 3 coolant pumps on this machine. 2 of them are flood pumps, and 1 of them is a medium pressure pump that's 138 PSI. But now that we're on that, essentially we can add our high pressure coolant systems, which are single filter, double filter. Well, they'll automatically switch between filters while you're running, and those are capable of 1,000 PSI. The turrets on these machines are capable of 1,000 PSI through the turret. Both spindles have C-axis, and it's a direct index of the C-axis, so I don't have to worry about slowing things down and it finding C. It'll automatically go to C0. If I need more power for milling, then I can actually, both spindles have a disc brake on them for more rigidity while we're milling. So both spindles actually are 826 spindle noses, so I can actually put a chuck on there if I need to put a chuck on there. It's not a big deal, but again, it's kind of designed around bar work, but some chuck work as well. There's many CNC options that are included in the control, whether it's hobbing, polygoning, rigid tapping, peck drilling, things you used to have to maybe pay for not that long ago. Essentially, the control comes loaded up with all those options. If I want to, as far as part ejection, we've got a parts catcher here that's actually capable of front ejecting a 5-inch long part. If I want to have something that's longer than that, then I can actually put what we call a long work piece carrier in here, and the part ejector would come out. I'd have be able to evacuate that longer part through the sub spindle, and essentially it would have a lower chip conveyor and a tray to contain the part, and it's all enclosed, so you don't have to worry about anybody sticking their hand in there and getting hurt for the most part. Bar feeds, we actually sell our own bar feeds, whether it's a short bar feeder or a 12-foot bar feeder, but essentially we can put any bar feed on the machine. The machine comes standard with an assortment of static holders, so double ID tool holders, turning holders, cutoff holders, an assortment of those. And it comes standard with hard inch S22 collet pads, not the pads themselves, but the work holding for those pads, which is essentially what you see here on the two spindles. And the parts conveyor is also standard. The chip conveyor is also standard. And one other thing I want to comment on as far as accuracy of the machine and just being able to change tool holders out, the fit tolerance between, this is just a turning holder I've got in my hand, and the fit tolerance between these pins and these bores that these locate on are so tight that, you know, you can rely on being able to take the tool holder out, put it back in the machine, and not have to dial it in. It'll be there day in and day out. That's something that's been around on Miano for years. I'm going to hand it over to Zach Hughes, and he can kind of take you through some capability and some control features.
This is what it looks like when we have superimposition. So this is what triple turret capability looks like in certain situations, where the sub spindle is working on the back side of the lower turret and the lower turret is working on the main spindle simultaneously as the upper turret is independently machining on the main spindle. Now you're going to see them break into individual programs. So the sub spindle is going to be working with the lower turret. This is actually going to be a dynamic polar milling program. So we don't have a y-axis on the lower turret, but we're kind of milling y-axis features and off-center. The way that that works is the C-axis is actually acting as a y-axis. So the X is moving in and out, and the C is following it, and it allows us to cut y-axis features. So the way that that would be programmed is you program it just like normal XYZ code. And then there's a G12.1 that we put in there, and the machine takes care of all the calculations to be able to make that possible. You're going to see the upper turret here working on the main spindle. That's going to be machining the OD flats. There are lots of different ways to tackle this. We could have done a polygon milling program. We could have also done a polar milling program from the face. Any one of these works. I just chose to use an X-axis holder here. So on the bottom turret on the sub spindle now, you're going to see a chamfer program. So again, we do not have a y-axis. So normally you would think that you need a y-axis to be able to mill those flats, but we're actually going to be using the G12.1 again, and the machine's just going to be able to mill all these features using the C-axis and the X-axis. On the upper turret now on the main spindle, even though that we have 6,000 RPM capability with our live tools, this is actually a speeder head. It's a 5-to-1 speeder head. So I think around here we're doing a 25,000 RPM spindle speed. It allows us to drill much faster with a 60,000th drill. So on the lower turret on the sub spindle now, you're going to see an engraving cycle. In this engraving, if you look at the part, we do not have a y-axis again, but it looks like you need a y-axis to be able to do this engraving. The way that that's possible is that G12.1 again. For some reason that we needed a y-axis, if there was an offset feature on the OD of the part, we can use the upper turret because each turret is capable on working on each spindle independently or simultaneously. So on the upper turret now, we're going to be chamfering the ID of those holes. Now we're going to be doing a radial polar milling cycle. It kind of works the same as doing a face polar milling cycle, except it's on the OD of a part. So it's allowing me to chamfer all these flats without using the y-axis. It's just a little bit faster than moving up and down with the y-axis. And I'm only climb milling here as opposed to climb milling and conventional milling as if I was using the y-axis. So here we're boring the ID just to finish it up and remove the burrs. And now we're going to start our part ejection cycle. So this is an included option on every Miyano BNE. It's going to be a parts catcher arm. The parts catcher arm will come up to the sub spindle. It will grab the part and then drop down onto a parts conveyor and eject outside of the machine. So here during our cutoff cycle, you're going to see a quick pullback. It's only about 100 thousandths. It only takes a second or two. And the advantage of this is actually doing a torque sense. So it's checking to see if our cutoff broke. If our cutoff broke, it wouldn't have cut all the way through the material. And it would know that it's still attached to the main spindle when it tries to pull, and it would alarm out immediately. This prevents lots of tools breaking after the cutoff during our next part cycle. This is going to be a better example of superimposition, so it really shows off the 3 tools in the cut at once. Here we're going to be pinch turning on the main spindle, which is very popular, and we're going to be drilling on the back side of the turret at the same time. This is a huge time saver in the industry and really what sets us apart to our competitors. So here we're going to be grooving on the main spindle. Right now the sub is just following, it's not doing anything. It's just getting ready to finish this face on the back side. So we don't gain full triple turret capability, but a lot of times we can save quite a bit of time by finishing on the back side at the same time. So here again, you're going to see us boring with the upper turret, finish turning on the main spindle with the lower turret, and finish boring on the ID with the back side of the lower turret on the sub spindle. So here, this is really going to set us apart in the industry, is we're actually going to be turning on the upper turret or grooving, and then we're going to be threading on the main spindle with that turret, and on the back side we're going to be threading simultaneously. So the sub spindle is actually following the turret and keeping up with the threading cycle on the back side as it's independently threading on the main spindle. So we're not just limited to superimposition with the lower turret, this is going to be showing superimposition with the upper turret at the same time. So now the upper turret is going to be drilling on the main spindle, it's going to be turning on the sub spindle, and then the lower turret is going to be doing its own thing as it's turning on the main spindle.
Can you hear me? Testing. It's loud enough?
We're going to display some shell mills. These are going to be geared down holders. So we have 6,000 RPM tooling on both the upper turret and the lower turret. But these geared down holders allow us to spin at 6,000. The output is actually going to be at 3,000 RPM. And then as it cuts, we gain double the torque.
Randy.
This is going to show a better example of the superimposition using the upper turret on the main spindle and the sub spindle, with the lower turret working individually on the main spindle. Mirror imaging. This is doing for great main turret. This is a waving one straight right up the other turret. Flats. So some is out the part for the next part length, so we're ready to go, so we don't have to use a bump stop, and then it's going to cut off and finish the transfer.
The main spindle is a 20 horsepower, 5,000 RPM spindle. The sub spindle is a 10 horsepower, 5,000 RPM spindle. Both the turrets are 6,000 RPM spindles, and every station is capable of live tooling. So as you saw in the video a little bit, you really got to see superimposition in that video. So that's what really sets us apart in the industry to everybody else. The way that that's possible is that the sub spindle actually has an independent x-axis. So that x-axis is capable of following either the lower turret or the upper turret as it's machining independently on the main spindle. So in the video you saw lots of different examples. We're not just limited to turning, we can actually do threading, boring, grooving, anything in superimposition. So as the main spindle or the turret is following on the main spindle and machining independently, the back side of the spindle, sub spindle, is following the turret and catching up to it and being able to machine. So I'm going to show a little bit of features on the control here. So this is actually our holder set page here. So this is where we actually define the holders. Now what this allows us to do is we actually can just call up the holder, and every holder is serialized if you're confused on which serial number there is. And it's actually engraved in the side of the holder if it's from Miyano. So here we actually can call up the holder, and for the diameter, for example, normally on most machines you actually have to put in a data here from the turret to the center line of the holder. So this actually wastes a lot of time. Normally people have that number written down, but you still have to put the information in. Instead, we can actually call the holder up, and when this is 0, that means that this pocket is on center line to the main spindle. So that makes it very easy. It's just kind of ease of use things. This actually has a number in it because that's a boring bar. So in a boring bar, we can actually just put the F dimension in, the dimension from center line to the tip, and then we're pretty much ready to go. There's really no touching off in diameter here. And then at that point, we just have to touch longitude off, which is Z, and that just makes it very easy and quick for setup and touching tools off. So all this information is actually saved in the program in the end. So instead of saving just here and having to change it every time, we actually save it back to the program, and this is all output with one program. So when we want to reload this job, for example, if we have an obligation like 10,000 parts a year, for example, and we don't want to run all those parts at once, we just want to fill in when we're not busy, we can actually, if you have the resources, you can take those holders, you can put them aside on a cart, and then do other jobs in between that you need to get done. And then when you are slow and you want to run that job again, all you need to do is bolt the holders in, you put the pads in, and then you're going to recall the program, and it's going to ask you, do you want to load this information back into the machine? When you hit yes, it actually pulls all the information from your program, puts it back into the machine, and you're basically ready to go. You don't have to touch anything off. There's no messing around with it. You may have to change a couple offsets, but that's after you run the first part. So it's pretty easy, and our changeover time is very, very low when you do something like that. So a couple features here. We have a check mode. So auto mode is for running automatically, and then check mode is when we're setting up. So there's a couple extra features that we get here in check mode. One of them is high-speed check. So say you want to get a cycle time for the part for a customer, you can actually just write the program in here. You can do high-speed check. This is checking two things. It's checking to make sure that there's no errors in the program, and then you can actually get a cycle time. So when we hit high-speed check, I hit cycle start, the machine is actually running through. It's not actually moving, but it's running through the program to make sure there's no errors in the program very, very quick. And then in the end, it's going to give us a cycle time, which is pretty accurate within about 10%. So this is definitely a time saver. It makes it very easy and reduces the errors in the program as you go. So there's also another nice feature when you actually go to prove it out. We actually have this handle mode. So what handle mode allows us to do is once we turn it on and we hit cycle start, the machine is actually going to start to run. So we can go over here to our handle, and we can actually go forward. And the second that I stop, this is actually running through the program. But when I stop, the machine stops. So we can actually continue to run. Everything's going to start. It's going to go down like it's going to machine. And say that it was too close, I wanted to go back a little bit. I can go back to an extent. So I can actually go backwards a little bit and rewind a little. So I can go down and start to machine. This is very easy, and it makes it very easy to set up and prove out a part. So some of the things that I want to talk about is MC data. So MC data allows us to save the information of the part in here. So bar stock diameter, how far we want the part sticking out of the main spindle, how far it is out the sub. So we actually don't have to use a G5456. The machine actually knows where the part is in the machine at all times. And again, this is saved in the program. So if you notice in the video, our tool changes, when it goes to do a tool change, both the sub spindle backs up just far enough, and then the turret backs up far enough so that we can change tools right off the part, because it knows the longest tool in the turret, so it can instantly rotate and clear the part and not hit anything. So our chip-to-chip time is almost nothing on this machine. It's very, very limited, and that's another thing that really sets us apart. So I kind of hit on all the details of the machine. We're going to jump to questions and answers, and I'm actually going to bring Les back into this for that.
So Zach, we've got a question. Somebody's asking whether or not the top turret has the Y-axis on it. So that is the only turret that has the Y-axis on this machine. and I've got 80 millimeters or 3.2 inches worth of stroke on that y-axis. One of the other things I kind of want to point out here is as far as unique tool holders for this machine and utilizing the superimposition, not only did that turning holder that I showed you earlier with the double turn and working both sides at the same time, but we actually have tool holders that would have an OD turn on one side and an ID tool holder on the other side. So I could actually be turning and boring instead of turning and turning, which is what Zach had showed you here. So a lot of capabilities, and for some reason, you know, we need some other type of tool that doesn't exist. Our R&D department is capable of designing and making those specific tool holders, and that's how that whole department came to be years ago, was really a need that maybe didn't exist for the machine, you know, off the shelf. So from the high pressure coolant pumps to automation, we're actually working on a large automation project now for a customer where we're going to be using chucks, not the collets, and we're going to be chucking on a part that we have to load into the machine and unload and tray. So that'll actually be a robot cell with vision, and we're going to pick these parts out of a bin, essentially. So that's an order we just received recently. So we've done a lot with automation, different types of automation, mechanical or robotic. So we're fully capable of handling all of that in-house. And I think that was it for questions. So I think we're.
One thing that I want to hit on real quick is Les mentioned our coolant capability. So I'm actually going to close this, and I'm going to show you the standard coolant here that comes with the machine besides the 1000 PSI option. So you can see here, oops. So you can see here the standard coolant, and also it's kind of hard to see the high pressure coolant here because it's kind of covered up and it's splashing the glass now. But we don't have any issues with coolant right from the factory. So I know that sometimes that's an issue with machines. So I just wanted to hit on that real quick. Any other questions? All set?
I guess there's another question where somebody's asking whether or not this is the single, double, or triple turret machines. So essentially, this being the double turret machine we talked about, some of these other machines are single turret machines, and there are triple turret machines that are special ordered from Japan, 2-inch and 2.5-inch machines, but those are a little longer lead time at this point. And those triple turret machines are triple Y-axis on all the turrets.
Hi, my name's Dave Doobie, and I'm with Marubeni Citizen-Cincom. I am the Electrical Engineering Manager for the Automation Department, and we are here to talk about the BR200V Vacuum Ejection and Palletizing System. Our machines are capable of making very small parts that sometimes can be lost in the normal ejection system of the machine. The vacuum systems are capable of ejecting every single part that is made on the machine without being lost. There is zero cycle time once the part is ejected from the subspindle into the system. The part deceleration funnel is used to decelerate the part as it's ejected from the machine, so there is no part damage to the finished part. Two trays in the system provide an exorbitant amount of unattended runtime for your machine. Random sample feature allows parts to be removed from the system so they can be measured and machine verification. There are different types of tray designs that are available throughout the system so that you can have SPC control and or straight running capability. The L12 vacuum system was designed to capture all small parts made in the machine. The same concept and system can be designed and used on other various machines in the Citizen line. Now we're going to talk about the K16 bone screw unloading and palletizing system. As the screws are unloaded from the K16, there are different types of screws that can be made. Depending on the head style of the screw, different options and modes can be selected to unload the screw. The modes available for injecting screws would be a direct grip from the subspindle or the unloading feature, as you're going to see here, to be able to grip the screw in a place where it is stable. There is no added cycle time to the machine from this point on as the screw is unloaded. These bins are designed with sample bins and run bins. The sample bins will contain a single part which during inspection can be measured, one on either side of the run bin, to determine that the screw is within spec. If the screw is within spec on either side of the run bin, then all parts in the run bin are good. Our random sample feature, which we provide on all automation systems, is capable of unloading a single part to the exterior of the unloading system so that it can be measured and verified. Trays can be removed temporarily from the system and replaced without losing sequence in the tray. K16 bone screw unloading system was designed to unload a multitude of different style bone screws from the machine to prevent any kind of damage to the parts. And also it allows for SPC control during inspection.
What are we doing?
Next, we're going to talk about the L220 blank loading system on our new L220. This system was designed to help feed the U60J option on your L220. The system contains a bulk hopper for your blanks, which deposits parts as needed onto the vibratory table. The parts are circulated around to be deposited down the feed track. Parts can be brought into the feed track in different orientations. Here you're going to see an overall operation of the system and the way it actually works. Next, you will see a detailed description of each individual move of the system. You can see here when the vision system takes the picture, it knows that the part was oriented incorrectly. It rotates the part and places it into the qualification station. Once it puts it in the qualification station, the robot grippers rotate back to the same position every time when it loads it into the U60 Jag. This screen shows how to set a new part number into your system. The system is capable of containing 255 available part recipes for the different types of blanks that may be used in this system. So that was our L220 blank loading system. The last three examples of the automation that you just saw were a small portion of what Marubeni Citizen-Cincom's automation department can do for you. If you have interest in any one of these automation systems or a more customized system, please contact your local distributor for more information. Thank you very much for watching our presentation today.
Okay, so before we answer any questions for the automation, there's about a 30-second delay that goes through to the user seeing. And so I'm going to cover a couple questions that were put in right at the end of the BNE. And so I'm going to start with, when you are working at the same time with spindle and subspindle with the same turret, how the machines know that they're not going to hit a tool when it's waiting? Well, what happens is we have what's called superimposition. So if you tell the one turret to go to a position, if it's X 1 inch and Z 0.1, it's going to stay there to the part. So as everything's moving around, it's as if it's not commanded, and it's going to stay in front of the part. So it's kind of automatically done through the system in what we call mode selections and superimposition. To get more information on that, simply please contact your local distributor and they can go into much more detail. And there's a second question is, with the handle program testing function, is it possible to slow down the turret rotation? And that's a very good question, and absolutely yes. When we're in handle mode, we call on-machine program check. When we're going through the process, if we go down to 10%, everything's 10%, including the turret rotation. So everything is timed except for the hydraulic of the clamp and unclamp, but the rotation of the turret is done in a slower rate. So thank you for those questions, and we will now go to Dave Doobie. Is there any questions that on our automation process? Now's the time. And Dave, are you there?
I am.
So if you would like to just summarize or come up with some topic, please continue.
So a lot of our automation systems were sort of designed based on some customer needs. And generally, it's the customer that knows what they need to process their parts. And any type of custom automation that's necessary or that a customer may require, we're capable of handling. As earlier as Les said, we do the robotics. We specially design mechanisms to either help load or unload parts into a system. As you saw, we use the vacuum ejection systems. We do a basic vacuum ejection system too, where we just kind of drop it into an external bin, which is very helpful, low cost. Some people want to know, where the advantages of the traying system, and basically the traying system advantage is covered in the inspection time post-process. So when you have a tray full of these tiny little parts that come out of your system and they need to be inspected, we use the SPC style trays so that you have a sample bin and a run bin. And then the parts that are in the sample bins are measured, And if parts on either side of a run bin are measured to be good, then all your parts in the run bin are theoretically good. So it saves a tremendous amount of time in inspections. These baskets are also capable of being put into a washer so that the parts can be washed and cleaned in a bulk manner without having to change them, put them into different containers. So there are a lot of advantages to these little systems that will help the customer in the long run, and the return on investment is pretty decent. I mean, most of the time, our customers see the advantages right away, and then having multiple systems going with these on it are very advantageous. So if there are any other questions, now is the time. Other than that, if you do have any specific needs or wants for any type of automation, please get a hold of your local distributor and they will get in touch with us, and we can do either a Teams meeting or some sort of in-person meeting at some point in time to determine exactly what would help you out. Thank you very much for attending.
And that's all we have, Dave. Thank you for the great presentation. And we're going to move on here. So next we have a small spot of what we wanted to present to you, just called New Technology. And here's a message from our bar feed product manager, Mark Zarbach.
Hello, and welcome to MCC Tech Days. My name is Mark Zarbach. I am the bar loader product manager for Marubeni Citizen-Cincom. Today, I would like to show and explain a new technology that we've been working on for future development on our A320, C320 bar loader. We have developed an Ethernet link between the A320 and the C320 that will give us almost real-time communication between the machine and the bar loader. Not just signals, but actual data. With this, we can now send information from the program to the bar loader by using macro variables like overall length of the part, short feed safety, long feed safety, and torque setting for the pusher. We also receive from the bar loader using macro variables like bar remaining, parts remaining, and pusher position. And here's an example of almost real-time info sent from the bar loader to the machine. As I move the pusher by hand, see custom macro 443. Now with this type of information being sent through the program, if the operator or the setup person forgets to send the bar loader info, the information will be sent by program. We are also working on having this information of parts remaining and pusher positioning showing up on our operator screen. Another new feature that we'd like to add to our bar loaders is last bar sensor. So if the lid is closed and the machine is an automatic and the last bar is loaded into the channel, now with the lid still being closed, we have a warning light blinking that states that there are no more bars left in the bar loader. Please be on the lookout for this option and Ethernet connection between the C320 and the A320 in the near future. Thank you for your time, and please continue on watching the MCC Tech Days. Thank you.
And so that was a great new feature that we're putting onto our C320 bar feeder. We hope that you like that concept and see other things that we might do in the future. And from right now, since we did do a Miano product, the BNE, we have a presentation from one of our distributors. As we get into IMTS, our distributors are a big part of our whole event. And many of them wanted to give us their small videos of review of them and what they're doing locally. And this is from Productivity, who are residing in Minnesota.
Hi, everyone. My name is Andy Archer. I'm the Director of Machine Tool Sales here at Productivity Incorporated. Today I'm standing in our Cincom Miano showroom at our headquarters here in Minneapolis, Minnesota. We also have facilities in Cedar Rapids, Iowa, and Omaha, Nebraska. And our sister company, MMT, has offices in Denver, Colorado, and Salt Lake City, Utah. First of all, I want to thank MCC for the opportunity to be here and to join this event. It is truly an honor. Second, and maybe more importantly, I'd like to thank you, our customers, because without you, we don't exist. Thank you for being here. Today, we're going to show you a little bit about what productivity has to offer, and then we're going to turn our focus to the Miano BNA42 GTY, and we'll show you the unique features that this machine has that will help improve your bottom line. I hope you find this presentation helpful and informative. Thank you.
So at Productivity, we are a comprehensive machine tool distributor. Productivity offers our customers a unique selection of services and sales. Most of our competitors have maybe a line of machine tools. We have a range of a line of machine tools that cover whatever a customer needs. In addition, we have a really strong service group, also an applications group, a tooling accessories group, a rotary repair. We think almost everything that a customer would need related to metalworking manufacturing. But we've always had a really strong emphasis in local service to do our absolute best to make sure the customer gets up and running as fast as possible. Our training group, we provide training almost every day for Haas-related machines. We also do on-site training for our customers as well. That's extremely important. People need to know how that machine tool works, not just what it can do. We also have a used equipment division that will identify equipment that's old in a customer's location. We'll tag it, look it over, and in many cases, somewhere in the United States, when this goes on an auction, we'll pay much, much more than anyone ever expected they would get by just having a local auction. We also have a group that provides tooling accessories. They are outside salespeople who are really dedicated to helping customers figure out ways to produce a part faster and better. We also do preventive maintenance. It's a lot cheaper to have your machine brought down to have it maintained on a regular basis than to have a problem and then it's down on an unscheduled basis. Our success is really what we see in our customers' success. When people think about productivity, hopefully they think about us as being fair. We provide excellent machine tools and services. What we also provide is quality services, integrity, and be the best we can for our customers.
The 5 gentlemen seen here are just part of our applications engineering team that is focused on turning, multitask machining, and Swiss-style turning. Combined with our staff in Cedar Rapids, Iowa, and Omaha, Nebraska, collectively they have over 150 years of experience in manufacturing. Whether you lack internal expertise, time, and manpower, want greater accountability, or just don't know where to start, outsourcing your CNC engineering project to Productivity will help you solve your toughest manufacturing challenges. They are here to help you get the best of your investment in your Cincom or Miano machine.
All right, well, let's get to the machine here, the Miano BNA42 GTY. This machine is built from the ground up as a bar feed machine to handle the specific requirements of a bar feed machine. Bar feed machines need to be extremely rigid to handle vibrations that might be transferred through the bar, rotating at high RPM. And they need to be really thermally stable so that, they're doing high production over long periods of time on parts that require extreme high precision. Well, let's look at the bed. The bed is the foundation of the machine, and we all know the foundation has to be solid. The design on the BNA42 GTY is single piece, heavily ribbed cast iron. This bed provides for high accuracy over many years of use. It also provides for thermal stability and vibration dampening. Let's take a look at the slideway system on this machine. The BNA42 GTY uses hand-scraped box weight construction. Again, this gives us higher rigidity and better vibration dampening than other weight type systems. A lot of competitors use roller guideways or they use ball guideways, and they just don't offer that same level of rigidity and vibration dampening. Both of those things vibration dampening and higher rigidity will provide much better tool life over long periods of time as well. Next, we'll look at the spindle. The spindle is really the heart of the machine, and the Miano spindle design is unique and extremely well built for bar feed applications. They have double row cylindrical roller bearings in the front for rigidity, angular contact bearings for precision, and 2 sets of double row cylindrical bearings in the rear for added rigidity. The spindle also has a very thick walled construction, which again just assists in heavy duty cutting and vibration dampening. This brings us to the control. The control is the Mitsubishi M730VS, and this is really the difference maker on the BNA 42 GTY. This control uses all of the technology that Cincom has developed over the years for faster setups, fewer errors by your operator, superimposition cutting where we're doing simultaneous operations, still using very easy programming technology. And so if you have not seen a demo on this control, I urge you to contact your local dealer and get a demo on this control. It really is the difference maker. So when you put those basic design features together with the tool layout on the GTY, you come up with a machine that is simply outstanding for bar feeding work under 1 5/8". We have the gang slide that has both turning tools and live tools, which allows for pinch turning or pinch milling in conjunction with the turret. And then you have the tools on the gang slide that face the rear, so we can be working the rear side at the same time as we're working the front side with the turret, and the turret can work both the front and the rear. So a lot of capability here, a lot of flexibility. It all comes down to just simply making your parts faster because of the overlap simultaneous operations. One more very important thing to add there is we have Y-axes on the gang slide and Y-axes on the turret. They can be used together on the front side for pinch milling, or they can be used independently. We can be milling on the front side and milling on the back side simultaneously. I hope you're still with us, because now comes the fun part. No more words, just watching the BNA 42 GTY in action. Thank you for watching, everyone. Again, I hope you found this helpful and informative. I'm sorry we didn't have the chance to get together at IMTS this year. I hope we'll see each other down the road. Until then, stay safe. Thank you.
So we want to thank Productivity for giving us that review of the BNA 42 GTY. So that was wonderful. And from here, our next event is actually at 2:15 Eastern, and it's for our D25. We're going to take a break, and we'll just have this slide up for about 15 minutes here. And at 2:15, we will start our D25 presentation. Thank you, and please stay tuned. Here's a video from our distributor, PMTS.
I'm Randy Heck with Precision Machine Tool Solutions. We're the Mid-Atlantic distributor of Miano and Citizen-Cincom machine tools. Behind me is an awesome machine from Miano, the BNA 42 MSY. With its rigid boxway configuration and a total of 7 cutting axes, simultaneous machining of highly complex parts from bar stock is what the Miano Precision is all about. The BNA 42 MSY has a 42mm bar capacity, main spindle, sub-spindle, with a single turret, including a Y-axis. This machine will outperform most all other machines in its class based on 2 of its most important features: the X2 axis on the sub-spindle and the simultaneous machining capability. In this video, we will show you some basic simultaneous OD-ID machining. But before we get into the cutting, please pay close attention to the details so you can understand what having an X2 axis and simultaneous machining can mean to you in reducing cycle times, cost per part, and a greater return on your investment into a new Miano machine tool. Thank you.
This is Jim Kaczynski. I work as a sales engineer, and Jim is an engineering supervisor. I think you'll be in good hands in this presentation, considering Jim and I have a combined time around Citizen-Cincom machines of 53 years. So I think we'll be able to handle most of the questions. So we're going to be presenting the Citizen Machinery Cincom D25 Type 8 machine. And you know, I want to thank you guys for participating, and hopefully I'll have some questions at the end. I'm going to start out going over some key design features of the machine, and then I'm going to hand it off to Jimmy, and he's going to go over some machine specs, capabilities, control features, that sort of thing. And then we'll have a short video at the end that shows more capability on the machine. So we'll just follow through after Jimmy's done with his presentation. So the D25 Type 8 machine is a 12-axis machine, which has the B axis over here. It's capable of working both the front and the back of the part. It's basically a 12-axis machine, but if I add the cab bar loader onto this, it's actually a 13-axis machine because the cab bar loader is integrated. It's integral to the machine itself. So the machine looks at that as if it's another axis. The control on this machine is Mitsubishi state-of-the-art 800 control with extremely fast processing speeds, therefore minimizing a lot of the non-cutting time in the machine. So my side of things, as far as talking about the design of the machine, is really things that are somewhat under the covers you don't necessarily see or hear about. One of them is really even though it's a compact machine, this machine weighs slightly more than our previous 32mm machines, even the M32, and has larger ball screws as well. So in addition to the machine, there's actually 2 coolant pumps now, which actually for years it was only 1 coolant pump. So that second coolant pump absolutely helps coolant flow in the machine, and especially if you've got high pressure coolant in the machine. Another key feature, this machine is actually a guide bushing and non-guide bushing machine. So I can pull the guide bushing out and use the machine as somewhat of a chucker. And because of that difference in heat generation, what Citizen-Cincom has done with their machines that are switchable like that, convertible, is they've actually added thermal compensation sensors because they recognize there's a different amount of heat when you run guide bushing and not guide bushing. And that's all basically integrated into the machine, and it'll actually compensate in both X and Y directions, which is typically where you're going to see the thermal growth in any machine anyway. The other key part of this machine is, in a lot of the Cincom machines, is LFV ready. So these machines are capable of, it's a Citizen machinery proprietary software that helps with shift control dramatically with whether it's turning, drilling, boring, milling, threading, that sort of thing. And customers, that's been around for a couple years now, and customers have, once they experience the LFV, which is low frequency vibration cutting, that's all they want in the machine. So it speaks for itself, whether I'm cutting nylon, Inconel, stainless steel, and you can definitely impact and control the chips that you're getting, so you're not having chip wrap on the machines anymore. The machine's got a centralized lubrication system, so it's actually lubricating all of the guideways and also the gearbox for the live tools. So that's all integral in the machine. So there's a lot less need for any grease fittings and that sort of maintenance. And both spindles and the guide bushing they have air purge in them, which is going to keep the debris, keep the spindles cleaner, and create some longevity there as well. So it's the spindle bearings it's a lot less frequent to have to change any of that stuff because we're making things completely clean. The C-axis, there's C-axis on both spindles, and it's direct engagement of the C-axis. So I don't have to worry about stopping the spindle and then rotating the spindle to find C0. It'll actually, from 2,000 RPM, let's say, you give it the C-axis indexing command, and it'll stop on 0. So there's a lot less time and lost time, if you will. That's another non-cutting feature that we don't see the time loss in there anymore. There's actually 2 different part unloading options. Essentially, there's people that are familiar with the M, kind of a popular product for that is actually what we call the gantry unloader. It's essentially a gripper mechanism that sits in the back working here. So if I have a part that's longer than what can be ejected through the normal parts catcher, I can grab it with that gantry unloader and send it out to the left side of the machine and get rid of the part that way. And that's in a contained area, it's covered. The other option for ejecting longer parts is actually feeding it right through the sub spindle. So the ejector would come out and there'd be a tube that gets replaced inside the sub spindle, And again, that part, one would feed the other part out, and eventually they come out to the left side of the machine, and they'll basically get dropped in, again, a safely contained area. And that long workpiece option is really, we can eject a part that's 20 inches long. And even though we've come up with options in our R&D department to eject longer parts, that's just what we get out of a standard option that's stocked in New Jersey for the most part. What you get really essentially, what you see inside this machine is a standard tooling package. So the B-axis, you know, the assortment of turning tools, this is all standard. These are live cross drills here, and those are all those live cross drills are all integral spindles. I can pull them out. And for instance, this cross drill here, which is a standard on the back side, is also the same spindle that I use here. So again, so what you see here is a standard machine. You get a static holder here, 3-position holder. A lot of these holders are all 3-position, whether they're static or other types of live. This particular one is going to be a standard as well, and it's actually able to rotate. Right now, Jimmy's got it on an angle, but it can rotate from 0 to 90 degrees. So that's a manual adjustment, where this B-axis is fully programmable. So I really got 5-axis simultaneous control on this machine. If I'm dealing with, you know, some complex machining with the B-axis, I can generate code for 5-axis simultaneous. I think that's pretty much what I have, and I'm going to hand it over to Jimmy. He's going to get into a little bit more detail, and we'll have questions and answers after we're done.
Thank you, Les. My name's Jim Kuchansky. I go by Jimmy K here in the New England office. So if you ever call in, ask for me. The Kuchansky last name gets confused with a lot of other names over the intercom system. So I finally go by Jimmy K here. Everybody knows who they're talking to. I'm going to try to elaborate a little bit further on some of the points Les touched on. I have bullet points. I'm going to cover them. At the end of this, we're going to show you a quick video of the machine actually cutting material, even though I am going to cycle the machine during this process. And then we'll have a brief question and answer after that. Thanks for being here with all of us today. Thanks for taking the time out of your day. Okay, the first thing that Les mentioned is the 13-axis we have available to us. So I'm going to have John step in here a little closer. I'm going to kind of point out the axes that we're talking about. And I'll also show them on the control so you can see manually how we move them. To start with, we have our X1 axis. We have a Y1 axis. This is a true 5-axis B-axis. We also have our C1, and we have our Z1, which is behind the covers there, where the bar is actually clamped, feeding through our guide bushing. The second set of axes we have X2, we have Y2, and we have about a 1.6-inch stroke on Z2 axis. What that does, it allows us to pinch turn, pinch mill, pinch groove, double simultaneous thread, double lead thread with one set of cuts. Basically, a lot of limitations. I have double saws I'll show you. So there's so many features with the pinch capability. Those pinch capabilities, I'll go into that in a second. So on the back side now, I've covered all these. We have our Z3 axis. We have our X3 axis. We have our Y3 axis. And we also have C2, which is fully programmable through milling interpolation. We can tie it in with our B axis. So we have the ability to 5-axis machine on the front side, true 5-axis. We can also swing this holder to the back side and use true 5-axis on the back side as well. What Citizen does awesome is they have modal commands. So many of you that work on FANUC controls, you may have head 1, head 2, head 3. You have to teach where everything is. On the Citizen machine, we use what we call, on this particular machine, our G700 codes. That gives me information as to where I am actually machining. Am I using both gangs on the front side? Am I using the sub spindle with both gangs on the front side? Am I using the B axis with the sub spindle? Am I using it on the main spindle? Or am I using the sub spindle over on the back working tools? With all that being said, the limitation really is here in your head on how to process parts on this machine. But the machine can pretty much do anything we ask it to do. The front side here, these two ID blocks, one lower, one upper, those are now standard coolant through. We have worked with tooling manufacturers to allow us to, their tooling, there's basically the blocks are slotted. So through their holders on the back side, we can put the tool holders in, and high pressure coolant comes down below here, and we're pumping to the block. So we don't have the interference of all the lines in the machine that are another area for chip contamination, catch, chip wrap, those kind of things. And that is on both front and right side and left side blocks. This particular block here, John, if you want to step in for a moment. So this particular block has 7 positions for the back side, 4 for the front. So we'll talk a little bit later about the capabilities on the back side. We may need more than 4 tools on the front side. So MCC, TNA, the accessory division, we have developed a convertible 6 or 7 position block. We give up the use of those 3 to the far side of the machine back tools, but now we have 7 tools we can use inline on the front. So that is a lot more capability on the front side. So that gives us 7 ID tools. And then with the use of our B-axis, that gives us 11 ID tools to the front side. The addition of 4 from the B-axis to the back side. So potentially 13 tools can be used through those couple blocks. Okay, I'm going to talk a little bit about the control. So I'm going to have John step in a little closer so you guys can actually see the control. So one of the things that's unique on this machine, and if you were here a little earlier, you probably saw a little bit on the cab bar feed, but the cab bar feed is a bar feed that's completely electronically linked to the machine. There is no separate control on it. So everything we do from the machine is controlling that bar feed. So right off my screen, I can menu select, and I can have bar loader operation. The bar loader operation, I can step by step through the entire loading process, open pushers, drop bars in, any of those kind of things. Material, if I choose to, automatically, if I have a bar remnant there, I want to get it out of the machine, I just select number 2, it retracts the remnant. I can load bar stock. I can just bring the pusher forward. Or if I have a bar sitting there and I need to get up to our top cut position, which is right behind the guide bushing, what that does for me is I can go through the entire cycle. It will go back, strip the remnant, check for no bar, drop the new bar in, and bring it forward to what I would do during normal bar change. So that's an awesome thing about the material. And then we have our bar loader set page. I'm going to show you MC data page shortly, but this information here, we have different positions of the bar feed that optimize the stabilization of the bar. So what this does is, based on information I give the machine with every program, it automatically recalculates all the things here. We run various bar stock lengths because we have a flag in the front of the machine. So we can run any length bar, the flag is tripped, and then we measure to the back of our guide bushing and then load bars. So if we're running random bar lengths anywhere from probably 3 feet a minimum to 12-foot bars, we don't have to worry about where that is because we measure from the front to the guide bushing. So bar shortage position is automatically calculated based on my part length through this auto setting feature here. So if I have a 6-inch part, we have educated the machine on where max feed is. So all I have to do is hit enter here, and it recalculates all my stabilizer positions, all my end of bar positions, all that stuff is done for me. So it's very easy, and all that information I'll show you shortly comes in with every program we load. So again, I just want to reemphasize what Citizen does. Instead of head 1, head 2, head 3, we put in a $3 sign program on this particular machine. We have 3 Z-axis, we get $3 signs. So what that means is when I look at a program, we see head 1, head 2, head 3 on the screen. But it is all one unique program. All that information, we don't have to load 3 different programs for any process we're doing. This information is all inherent to the program that comes in. Along with that program, we have an MC data page, So basically what we describe is our stock, how far do we want to index, what tool we're using for cutoff. Automatic cutoff speed, program speed is completely different. That's whatever we choose to do. How much material do I make for the part? How much material do I need for the part? Do I have an extended nose collet? What's my work sticking out of the sub spindle and the extended nose collet? What's my diameter to actually set the tools from the backside? And what is my actual part length? So that works as a counter for the cab loader, so we know how many pieces are left on the bar. Okay, so that information is actually, every time we download or upload a program, that information is called in and sent out with the program. Tremendous help. So we don't need to keep teaching tools every time we put in. We have the information in the program. What Citizen does with the tool setting on this machine, based on that information, we have what's called a preparation mode. Okay, preparation, all the tool pockets are taught 0 right in the beginning, so we know where everything is. In the prep mode, what it allows me to do is fine tune for tool thickness. Maybe we have an F dimension on a boring bar. You know, maybe we're running a knurl, which you'll see here on the backside, where we have to go way off center with it for 0 point. So we have specific tool setting. So in the case of any of these tools, what we have here is a manual set. It describes the diameter. So if we want to set diameter, we're using, in this case, the 3/8 stock we put in the machine. That's our OD. That's a known diameter. We put the tool in, we set it there. So now it's good for any other diameter. We can change diameters of material and not have to retouch that tool. We also have the center coordinate if we need it. So the centering is allow us to establish top dense center on all our turning tools. When we go to any of our ID tools, we have core, diameter, and longitude. That's the center of each pocket. We teach that on setup for calibration. So that, again, it allows you, if you have a diameter adjustment where you have a boring bar, you have an F dimension, and you don't want a G50 shift it, you can actually put that value in there. For many of you that don't work with G50s, it's actually like a tool setup data page. So we can accommodate stuff there. If we have something off center, we can do that. And we also set our length on any of the tools there. So one more thing on the MC data page I'd like to emphasize is on the first page where that information goes in. I quickly jumped over it, but we have our back chuck extended length. So if I cursor down to that, it actually shows you a picture. That's if we're running an extended nose collet. So we could put in the value of the collet. The machine does all the recalculation for us. The back work length, that's how far from that extension is the part actually sticking out from that collet. I'll escape that. In the manual mode, I mentioned I'd come back to this quickly after I talked about the axes. On the axes, it shows you all the machine axes through our manual mode, $1, $2, $3. So $1, again, X1, Z1, Y1, B1, X2, Z2, Y2, X3, Z3, Y3, and A7 is actually a servo axis. So our bar loader stays exactly synchronized to our Z1 axis when it moves. Everything is electronic, servo motor, just like anything you do with pinch turning, it's that accurate. The only two axes that aren't shown here for the manual mode are C1 axis, which is our full C axis on the main spindle, and C2 axis, which is our full C axis on the sub spindle. One of the unique things about Citizen code, internal to my programs, as they all stay together, if you're working with a Fanuc control, or even some of the other controls, not necessarily Mitsubishi with Citizen on top, we have the use of sub-programs. The sub-programs where you're used to doing an M98P 1234, you go out and find it. We have the ability on this machine to run sub-programs. We can use M98H1. We go search for a sub-program N1, M98H2, N2, etc. We have the ability to do that in all three $signs, which means any of those sub-programs, we're loading one main program that covers all the machining area, and we load the sub-programs with that program. So we don't have to load 8, 9, 10, 12 programs. We load one program. We also do have the ability to run from a card if we have an exorbitant amount of B-axis work, huge amount of memory. That's all done through a post processor. we have 5 axis on a line, we could have 1,000 lines, which would take up tremendous amount of memory. We can actually run that as an external card, so we don't have to take up all our internal memory space being used. Okay, so now a couple of the extra features on the machine is we have what is called our preparation mode, and then we move into program check mode. In program check mode, what the machine gives us in this mode, if we look at the control here, we have 1 block, 1 cycle, handle, and high-speed check. Okay, I'm shutting off the bar loader right now because I'm not using it. I'm going to turn on high-speed check, and this allows me to test the cycle to see about what the cycle time is, make sure there's no blatant errors, any of that kind of stuff. So when I hit cycle start here, you can see all 3 $ running simultaneously. They're all working together, utilizing our 700 series modal commands to tell the machine how I'm working. Okay, cycle time came out at 1 minute and 5 seconds. It's a pretty accurate cycle time, plus or minus 5% maybe 10% worst case, but I don't have to actually cycle the part to see what I'm doing. So what I'm going to do right now, so you can see the difference, is I am going to run 1 cycle so you can see the machine run, and then we'll talk a little bit about more of that afterwards. Okay, if John will just visualize the machine cabinet. So you just saw a broken cutoff detector standard. Okay, we're doing some standard work, a face operation, normal ID work, pinch turn operation. As you can see, tools are very close there, but plenty of room to get them all in. Okay, pinch turn, then we're going to go into a pinch milling operation from here. Okay, again, tight proximity, but I have 2 tools that are about 60 thou away from each other. I also have double saws above that if I wanted to pinch saw a long part, and then a back turn. Grooving operation. Okay, it showed the B axis, just the movement, how fast it is. And now we're coming into one of those 700 codes to be able to pick off the part. My subspindle knows exactly where the part is without having to teach it because of the information in the program and the use of my modal commands. I'm going to run this one more time so you can actually see more of the back work this time. But what I do want to show you, if John will just pan over here for a second. Okay, so we saw 1 minute 5 on our high-speed check. The actual cycle time on that was 1 minute 8 seconds. So with all the variables in behind and everything the machine's doing, the electronic check of the program running is very, very close to the actual cycle time we ran to achieve that. Okay, so now one more time in there, in the machine, so you can watch the back work running. So while the front work is actually running, pinch turning, all that, we're going in, we angle drilled or angle milled. We just did a circle mill to open up the pocket. So now machine's continuing on. We're doing the knurl operation I talked about earlier. Okay, ejection of the part. There's our ejection basket. So we can get about a 4.5, 5-inch part out of there. Okay, now this subspindle is waiting for the codes to say I'm ready to come in and get my part. Okay, the pinch mill. Okay, so that pickoff coming in, if I had milled an odd shape or I'm working with odd shape material, on the fly, I actually superimposed the pickoff spindle onto the guide bushing, or spindle synchronized with orientation on the fly. I can wait till that happens, then feed over the part, close my part, and I can do that on the fly. Pretty awesome feature on the machine. Okay, so now back to the control. That was your 1 cycle in comparison. So what I also have here on the control is when I want to run the cycle and I want to prove it out, I have what's called a handle mode. So when I'm in program check handle mode, When I hit cycle start, it jumps one line, but the machine never actually moves. So what's going to happen now is I have a very slow, a medium, and a faster handle mode. So while I'm in cycle start, when I start cranking the machine, okay, now John, look back in. I'm just cranking the handle mode now. So I was a little dwell there, so I got to go a little second faster here to get off my dwell because the dwell counted in. So as you can see, as I crank through, that's in my very slow mode. I go to times 10 of that. So now the machine will move faster. Okay, and it's through. So it gives me the opportunity to stop cranking. I can check for clearances, any of those kind of things. Okay, now I can go even a little bit faster because I know this is a good program. I'm not going to waste a lot of time on this, but it is there and available. But I will show you on the pinch stuff how good it is. So now I'm coming in. That was fast. Okay, but now I can slow it way down and I can look at what's happening. Okay, so now that if I see a problem, I have the ability to back out of that code. We go a little further forward. So Josh, so we can see it over here. Okay, so as I back up here, it's hard to see it in the machine because it's a small part, but I know, John, look at this display for a second here. You can see the numbers actually going back the other way. Okay, so it gives me a chance to correct things I may need to correct. The other nice feature is if I have something wrong with the program at this point, I can switch to one block. It'll give me, the machine reads 5, 6 lines ahead. It'll tell me there's an alarm coming up. So if I didn't pick it up during my program check mode, when I did the high-speed check, it'll give me an alarm here. So I'm going to go to one block and let it finish. Okay, now that's finished. I have a correct feature here. Okay, it's not going to let me correct it right there, so I can continue on. Okay, so now I can go back to one block, let it finish the block. We'll see if I can correct something. So now the error may have been in $1. It's one of the places I can correct it. If I had a typo, a double decimal point, or anything like that, I would be able to correct it, come back to operate on the screen, and continue on. So like now I know the program's good, so I'm just going to let it finish up the cycle. So pretty much you've seen the cycle run, you've seen how the program works. One last thing I want to show you in the edit mode. If I happen to make a typo when I'm putting the program in, if you're not using a post and you put the code in by hand. So if I come down and I make a mistake, like my finger, I get a stutter finger. When I enter that, I put in multiple decimal points. It came up, said I have multiple decimal points, you got to fix it. So now I can fix it. So now it goes away, and inside the cycle, it would do the same thing if for some reason I missed it during my high-speed check, or I didn't do a high-speed check. The last thing I just wanted to show on the control is all of us on the older Citizens, we used to have our maintenance parameter button. With the touchscreen control, all the stuff is up here now, so I can select what I want. And then everything I want to do is right here in front of me. Okay, whether it's manual MDI, communication, offsets, tool life, any of the zero execute, variables, structures, what do I have? So it's all here now, right on one page. We don't have to find the page. It's all here for us. Okay, the last thing I wanted to touch base on, Les mentioned early that we have a convertible machine. Right now, this machine is set as a guide bushing machine. So that is one option. The second option was to remove the guide bushing. The headstock is allowed to travel forward, and we can use it in a guide bushingless mode. So the part's actually chucked, and now we can machine still using our same tools on the front with the part actually chucked. Good length to diameter ratios. It works out. If you got long, thin parts, you want to run sliding headstock. The last is our adaptive guide bushing. It's a double taper collet that we put into a system that's pneumatically pressurized. So when we close the system, this is pressurized to about 60 PSI. What that allows us is to run varying bar size material, aluminum, copper, plastics, brass, and we don't have to mess with that because of the size of the bar varying internal to the material. So we have plenty of more information on this kind of stuff, but this is a great system if you do not want to grind your material or you cannot grind your material because it's not cost effective. So it's something to keep in mind. All right, so now what we're going to do is we're going to, I'm going to have John turn around real quick and face this screen. What we have right here is on the back work block I showed you and Les showed you with some of those tools. Those are all the tooling capabilities for the positions on the back side. So as you can see, there's a tremendous amount of work to the back side that we can use this machine in addition to the B-axis on the sub spindle. So that was one last thing I wanted to show you. I think we're going to switch to a video now. It's going to actually show you the machine cutting parts. It's going to show you a lot of the features that are discussed here. We're going to do that. We're going to come back after that live, and we're going to do a question and answer period for as long as we have or whatever questions come in. Thank you very much for attending today. Hope to all see you soon. Okay, Brian, go ahead and run the video.
Here we've got just showing some separation between the back spindle and the main spindle, doing some drilling on the front, some turning on the back side, and now we're going to get into pinch turning, where the Z2 axis on the left side is going to follow what Z1 is doing, but do its own thing as well. We've got pinch threading, and we're back to pinch turning. And then we're going to change tools. We're going to go into pinch grooving. And then we're going to show pinch milling. Even though these flats are directly opposing each other, I could actually produce two different flats in two different places if I wanted to because of the separate Z-axis on the gang on the left. And now we're going to 5-axis simultaneous milling. And we're just cutting a port at this point. And this is showing a little bit of the back work. I've got 4 rows of tools, and I can have 3 tools in each one of those rows, so I can have a total of 12 tools if I wanted to. In this particular case, I've got 8. You can see the top holder that's set up as a cross drill. That tool can be manually rotated 0 to 90 degrees. And I can have live tools on all 4 of these positions. And now we're going to show an actual hobbing tool mounted on the B-axis. This is going to create the straight gear. Once this is done, you'll see the B-axis rotate, and the same hob will create a helical gear. That's just one of the many capabilities of utilizing the B-axis.
So there is one question, Jim, if you can hear me. Is the guide bushing for varying material, which means our adaptive guide bushing, available for the other Citizen Swiss machines? And actually, the answer is yes. We have it, our adaptive guide bushing available for most all of our Cincoms. If there isn't any more questions, we will continue.
The tools you see in there, we're running ER16 collets. Okay, some of the other tool holder specials run ER11 collets. Our stick tool sizes, the cutoff position on both sides is a 3/4 pocket. We have, then the balance of the tools are 5/8 pocket. The standard ID tooling is 1 inch, okay, with blocks available to run 3/4 inch if we need to, based on that picture we showed you before we went out to the break. I think that pretty much covers the general tooling. Again, our sales flyer shows you all that, so you could contact your local sales rep or distributor, and they can supply you all that information. But in general, we're dealing with ER16, 3/4, 5/8, some ER11, and if we're using our static 1 inch holders, ER20 collets on those.
One other question that came in was, where do we get the adaptive guide bushing collets? Southwick and Meister, get them Southwick and Meister Hardinge, and also a company called Skillcraft. I also want to mention, I've got a customer they run copper material for years, and they had L20 machines, and they struggled with run out on these parts, and that's just a variability in the copper itself, and they could never get the guide bushing, conventional guide bushing set adequately for the long haul. So we ended up putting an adaptive guide bushing system on their machine, and it works so well that they've got 15 machines now running adaptive guide bushings up there, and it's been a complete success. So it may not be for everybody for everything, but in this particular case, it was awesome. One other thing I wanted to point out was, I talked briefly about the LFE and the chip control. This kind of sums it up a little bit and shows a little bit of an example of what we get from chips from turning. And that's going to be gone over on Friday. One of the presentations on Friday is going to just deal with LFE. And, hopefully you guys can make it, because it's such a great product that, it solves a lot of problems when it comes to chip control.
This is just a good representation of some different tooling that we have, so it does not have a narration. So I just wanted to let you know that your sound is working properly. And often you just see some of these different tool holders that we have available. It gives you an idea, and understand that even if you come up with your own ideas, I need a specific tool, please work with your distributor. They'll work with our designers, and we can make whatever you might dream up. We've done double holders, we've done front and back, we've done angled tools, all different electric spindles having to do with our own specifically made for us from NSK. Many different versions of holders that it takes ideas from customers, and then we start to make them. A huge one is the hobbing, shown here. Many years ago, we would get hobbing holders out of Japan, and it was quite expensive because we didn't sell very many. So our designers here in the United States found ways to take the same holder we use for other features and multiple use it. Use it for hobbing, use it for milling, use it for the back spindle of another machine. So we were able to get multiple uses out of it, and it brought the cost down. And so some of our different hobbing options, we have many. Here's another great tool that one of our customers needed, and it lets us double the live tool capacity in the backside of an L20 or an L12 or an L32. And we have two versions, one for the L32 and one for the L20. So a tandem live tool that we're going to slide in, and it's powered from the top row, but then it subsequently gears down, and what used to be static on the bottom is now another live spindle. As many as 4 of those for 8 tools. And the L32 can have 6, or 3 pockets. Now here's a presentation of our hobbing spindle from one of our distributors, Spinetti Machinery.
Welcome to Spinetti Machinery. We are a very focused distributor concentrating on Marubeni, Citizen-Cincom, CNC Swiss, Citizen Miano CNC lathes, and FOBA laser markers. We pride ourselves in representing the finest equipment in their categories, attention to detail, and providing the highest level of service for our customers. The turnkey project we did for this customer is one of many examples of that. Now let's look at today's demonstration. We are pleased to have you with us today as part of the Marubeni Citizen-Cincom IMTS Demo Days for 2020. Today, we will be demonstrating a gear hobbing application on the Citizen L220 Type 10. A little about the machine. The L220 Type 10 is a 20 millimeter machine with a 25 millimeter upgrade option. It has the capacity of up to 34 total tools and has a Y2 axis on the sub for additional machining capability. Some features of the beveled gear project. We are using a gear hob attachment from Marubeni Citizen-Cincom New England division. We are using the LFV function, or low frequency vibration. That's part of the latest in the Cincom technology. The gear cutter is a special 3-tooth cutter from Gen Swiss. The goal of the project was to successfully make a pair of identical bevel gears to mate together in a housing designed by the customer. Originally, the customer was making a single gear in 5 operations, whereas we are now making the gear in a 1 complete operation. This project is this beveled gear, which is not a common thing to do on a screw machine. This particular beveled gear, instead of being at a 90 degree, it is at a 57 degree, which is even more unusual to run on a screw machine. This particular beveled gear required us to use this 3-tooth cutter, which acts more like a single tooth cutter than the normal cutter that we would use for a spur gear. We also 3D printed this particular fixture to hold the 3D printed gears we made of their printed part so that we could get a better understanding in the very beginning of this project. The customer's actual unit that they're doing this in is this one here, where you have 2 of these side holders that hold the gear that then fit into the housing, whereas then the beveled gears will drive each other. Thank you for joining us today. I hope you got a small glimpse into what the Citizen-Cincom Swiss CNC machines are capable of. Thanks to the Marubeni Citizen-Cincom New England office for the gear hobbing attachment. Thank you to Gen Swiss Tooling for the 3-tooth hobbing cutter and the turning tools, and Hardings for the collets, and our customer for allowing us to showcase the part. If you have any questions, visit our website at spinettimachinery.com or send us an email at info@spinettimachinery.com. Have a great day and stay tuned for more to come from Marubeni Citizen-Cincom during IMTS week.
Another video from one of our distributors, just to review some of the things that they're doing. Short and sweet and to the point, but a lot of you might not know that you're able to do eccentric turning on your machine tool. So on Cincom, instead of having to utilize just the CAM software to do so and come up with these huge programs, we actually have an option, and it's a G code. So you can describe the shape that you're going to machine. It could even be a tap off center or a thread off center, or in this case, an angled function. And this is done automatically through Cincom software. So again, if you have questions on these kinds of things, please work with your distributor. Of a quick review of an M532 that we did for our partners Mitsubishi.
Our next presentation is going to feature the L12 laser and our presenter, Randy Nickerson.
Welcome to our presentation today. My name is Randy Nickerson. I'm the laser product manager for Marubeni Citizen-Cincom. I'm here today to present the L12 Type 7 Cincom Swiss turn machine. I want to begin by reviewing some of the standard specs of the L12 Type 7 machine. This is a twin spindle, 7-axis mill turn machine that can handle bar stock from 1 millimeter all the way to 16 millimeters in diameter. There are 23 designated tool positions on 3 tooling plates. 8 of these tools are live milling tools, 4 in the front, 4 in the back. The 4 front live milling tools have 10,000 RPM capability, and the 4 back end-facing live positions are capable of 9,000 RPM. 4 of those could be stationary tools with the use of a drill sleeve. There are 6 3/8 square OD turning tool position, 8 3/4 inch round static end working positions, 4 facing the front, 4 facing the back. There's one 3/4 inch round static position located next to the back work block, back spindle, that could be used for longer tools like deep drilling. The main spindle has 15,000 RPM capability, while the sub spindle has 10,000 RPM capability. The standard, as on all Cincom Swiss machines, is the switchable guide bushing to non-guide bushing chucker type feature. The max part length for the L12 in one chucking is 5.3 inches in guide bushing mode and 1.2 inches in non-guide bushing mode. The max part length for standard ejection is 3.15 inches. Longer parts would need special routines or devices to eject the part. This compact designed machine is only 70 inches long and 32.3 inches wide. This machine is equipped with a Mitsubishi M70 control that allows us to get all the incredible functions of the Cincom software. There's our high-speed check feature to quickly process the entire program without any machine movement, to check for syntax errors, over travels, likely collisions, and displays the cycle time, again, without any actual movement. Our on-machine check feature allows you to use the pulse wheel to control the program's processing. You are controlling the advancement of the program by rotating the pulse wheel. And when seeing a problem, you could go in reverse, back up, get to the last end of block, make an edit in the program, and then continue back along. No need to start over from the beginning. Excellent for program prove-outs. There are many semi-automatic functions to assist in tool setting, cutoff, start position, and more. There's a full code list in the reference in the edit mode. This will even allow you to insert the code once you have chosen one. Also included is our eco mode to help you track the power consumption of your machine and shut down devices when they're not being used to save electricity, oil, and such. It'll save you money. Most all available control options are standard on our Mitsubishi controls. Full C-axis on both spindles, cylindrical interpolation, helical interpolation, slant helical interpolation, and milling interpolation, along with 40 offsets, Tool Life Management 1 and Tool Life Management 2, user macros, hobbing, polygon, rigid tapping with phasing, can cycles, constant surface speed, speed change detectors, differential speed rotary tool function, arc threading, variable lead threading, chamfer and corner rounding, geometric function, auto power off, and more. We also have our last part off feature, standard, which allows you to run one complete part, front and back, in one cycle. This saves time when you're setting up and money, since you don't have to run 2 parts to get one complete part off the machine, which is the normal practice in a Swiss type machine. We also have here, we're using our Cab 12 bar loader. This is a fully integrated bar feeder. It's controlled by the same CNC control as the machine. This gives us many advantages. The pusher can become a programmable axis. We can see where the end of bar is, which when doing long parts that require rechucks, it's critical to know that there's enough material to begin another cycle. We can also do auto set, which updates the end of bar position per part program. This also updates the bar support device's opening. This maximizes support and minimizes the chances of damage to the bar pusher. No more relying on the setup person to remember to adjust these every time the part length changes. Just push auto set and you're done. We also have here our L2000 laser system. You can see it back here on the back of the spindle. This is our laser system can be added to all our L series machines, our A20 machine, and even our Miyano BNA 42mm GTY machine. This system is also retrofittable to some of our older L series machines. We utilize the IPG fiber lasers within our system. IPG is the #1 fiber laser manufacturer in the world. This gives us the ability to cut through over 1/8 of an inch wall thickness in many types of material. With this system, we can do laser cutting, laser welding, and laser etching, all while utilizing just the one laser head. Our laser control system is deeply integrated into our control to allow us to command all the settings used by the laser from the CNC part program. We command focus, mode changes, power levels, all the beam settings, gas type, and gas or air pressure values. This can all be changed during the cycle. We have 3 gas supply lines that allow us to have up to 3 tanks of gas connected simultaneously. That all could be commanded or switched between from the CNC program. Having a laser on a mill turn machine allows us the ability to work not only from tubing, but from solid bar stock, which we have the ability to drill, bore, and turn to size before laser cutting. And then, when needed, we can also recut or use brushes to clean any burrs or residue from the part before it leaves the machine. Here we have a 2-piece part program from solid stainless steel bar stock. We removed 1 tool block to install the laser head, as you saw with the door open. Other than that, that 1 tool block is all that's missing. All the other functionality is still available. The biggest difference you might notice is that with the laser installed, we must run water-based coolant, not the oil usually seen in a Swiss-type machine. The tinted glass in the window is also a requirement to ensure the operator's eye safety. We designed our system with the user in mind. So if you know how to program a milling tool, you also could program our laser path. The only difference is that instead of turning on a rotating spindle, you'll turn on the laser beam. So we have the #1 Swiss machine on the market, using the #1 fiber laser on the market, supported by the #1 customer support group in the industry. How could you go wrong? The part that we're going to show you here running, whoops, dropped it. There's a 2-piece construction. So it runs one part and then the other. And you can see one piece is a stent-like feature that it cuts 385 little diamonds in that part, and then it gets in the backside and turns a diameter. On the other part, it's doing a tulip-like shape with the same stent-like cut, but just less of them. And when it's on the backside, it's using milling interpolation to mill these 4 little posts. When it's all done, they just fit nicely together to give us one little assembly. Again, I can run the cycle here. You can see it processing through. As you can see, when the machine is running normally with the tinted window and we have to use coolant, it gets very tough to see what's going on in the machine. Right now it is drilling using an LFV function, so it is really controlling the size of the chip, so I don't have chips building up on my drill. Once that's done, the laser will come in to start doing its cuts. I'll shut the coolant off so you can see a little bit. It's going to do those little tulip cuts very quickly, and then start the little stents. Those stents are cutting at 55 inches a minute. Very quick motion, as you can see when it's going through here. We typically use the coolant when it's running. The laser gas pressure just blows the coolant out of the way, so it does not interfere with the cut. Without the coolant on, you could get a little bit of discoloration in the part. Now we're going to show you a video in a few seconds of this part running without coolant, so you can see the laser working without the coolant blocking your view. Once that's completed, we'll answer any questions you might have. please submit your questions in the Q&A area so we can respond. Brian, please play the video. Welcome. Shown here is our Citizen-Cincom L12 Type 7 Swiss turn with a CAV-12 magazine bar loader, our Cool Blaster mist control, our vacuum eject system along with our parts carousel, and the MCC L2000 laser system. Here you see our part running using the standard and switchable non-guide bushing mode, while utilizing our patented LFV, low frequency vibration chip control function. LFV is an amazing feature that helps you control the accumulation of chips through deeply embedded axis to spindle synchronization. You can pretty much program the size of the chip that will be evacuated during the cutting. This can be used during drilling, turning, grooving, boring, and even threading. Next, the laser is cutting first a tulip-like shape, followed by a diamond stet-like shapes. We use the IPG fiber lasers within our system, which are available in many power levels. This allows us to choose the one that will give you the depth of cut needed while also maintaining the width of cut or kerf range that will meet your requirements. We are also able to do laser welding with the system using the same cutting head. Our system was designed so that those needed changes are just program commands, not physical changes that would require a second laser head. As we focus back, you see that the required work on the back end of the part is simultaneously performed during the laser or any other front end work that is required. On the back side, we are using one of the many standard control features, milling interpolation, to generate 4 posts on the back face. As a note, we are simultaneously using milling interpolation on the back and cylindrical interpolation on the front. This is due to the powerful Mitsubishi control of this Cincom L12. You may notice how fast the synchronized movements are happening while cutting the small diamond shapes at 55 inches a minute. Here you see our optional vacuum ejection system. This is especially useful on small or delicate parts. We are also using the optional part carousel to collect the parts. This could be used to separate your inspection parts from your production parts for SPC, or to keep soft parts from damaging each other during ejection. This tray can be configured to fit your part size requirements. Now you see the operator panel in screen display while the program is in process. The split screen is showing both channels as they run. Although it appears as 2 programs, it is one CNC program, but displayed like this for ease of following or understanding what is happening on each side. Very friendly user control. You see the additional monitor of the laser control system here, which displays the laser as it is functioning, and also a camera view of the beam as it is cutting, welding, or etching on the part. All the laser commands are being sent to the system from the CNC part program. We are utilizing the Citizen CAV-12 magazine bar loader, which can handle 2mm to 12mm size stock. The bar loader is interfaced with our Mitsubishi controls so well that we can see or check where the end of bar is located from the program. This is possible because the bar pusher has become an additional axis that can be seen and or commanded from the CNC part program. This is a very powerful combination. Our laser system L2000 is also available in many Cincom models, and also the Miyano 42mm BNA 42 GTY.
And we'll go to Randy live for any questions.
I hope you enjoyed that video. We did have a couple of questions come in. One of them was how we could control the chips that are being created during the laser cut when we're cutting tubing from flowing back into the bar feed. Well, typically when we're running tubing, we're running a coolant through bar feeder. So we have a high pressure coolant line attached to the pusher that's blowing coolant right through the bar stock, which is right through the part. So as we're cutting, it's blowing everything right out of the material itself and down into the chips. And the other question was if the laser could be moved, if you have an L20 machine and an L32 machine or an L12 machine, could they move the laser from one to the other? Technically, the answer is yes, but there's a lot of preparation for that. Once you put in all the wiring and everything into the machine, and then moving the head isn't a problem plugging it back in. It would be prepping the machines in order to be able to do that, if that was your desire. Another question was, do we use the same power level of laser each time? IPG offers a multitude of different ranges. Our system is set up to use air-cooled lasers. And they have air-cooled lasers from 400 watt, straight 400 watts, all the way up to 6,000 watt QCW. Beyond that, you start to need a chiller and all of the extra equipment to go with it. What I have here is a 150 watt QCW laser in this machine right now. That has 150 watts in any mode, continuous wave or pulse mode, or I can switch into QCW mode, and now I have 1,500 watts, but in pulse mode all the time. All right, and I think that's it for now. Again, hope you enjoyed everything, and if you got any more questions, by all means send them in, and we'll get an answer to you if your name is available on your question. Thank you.
Thank you, Randy. Great job. And so how we're going to finish up this presentation is, as I said earlier, our distributors are a huge part of our show effort, and our support team across the United States, 17 distributors, including Canada and Mexico. And just recently, last week, one of our distributors had their own event. And here's just a quick video that they sent us to reflect some of what they went through in the last week, and a little bit of review on two of the machines highlighted. So please have a look. The Millennium Machinery in our Indiana and Michigan area. Makes us feel as if we're at IMTS.
I'm Derek Bolin with Millennium Machinery. Today we're going to show you a few features on the D25 with LFV. We're going to do some pinch turning with LFV, some programmable B-axis, and some high-speed milling.
So, each distributor has their own way of presenting. And so it's good to see all of the different ideas some of our people have. So thank you, Millennium Machinery, for that video. And a great reminder of what IMTS usually is for us on the machine tool side is the setup. So here's one more presentation from Dynamic Machine of Detroit. And this is showing, often we have nice trinkets at our shows. And they made a part that got very creative with our very simple A20 machine. Please have a look. At the beginning, this actually has 5 different parts that are being made in succession. They actually are assembled to each other right on the machine. He's pressing the parts together as he cuts it off.
thank you for joining us today and coming into our showroom and spending time with us. Have a good day.
Thank you again, and you guys all have a great day. We're now going to end our event.